Hi, my name's Philip Carter. I'm a PM for F# and .NET. I work on the .NET team. I focus on F#, and I'm here to talk to you today about why you should use F#. This should be a pretty straightforward talk. Hopefully, by the end of this, you can have a pretty good idea of kind of what F# is all about, like what it is. You get an idea about like what you can use F# for. Kind of based on code that I show you and things that I tell you and so on. And then learn how you can do a few things with F# today. And then I just want to, at the very end, sort of reinforce how you can get started, because I want you to go out after this talk. If you have not tried F# before, go out and just give it a go in kind of your own environment, because there's a lot of great stuff going on with F# today, and you should totally use it. OK. So, basic facts about F#. It's a programming language. No, it's a functional programming language for .NET. By functional, that means it's, well, if you're familiar with functional programming, then that shouldn't be too difficult. It's kind of a way of, you model the flow of your program in terms of inputs that are passed to functions, and then the outputs are passed to other functions, and so on. And you sort of build like a functional pipeline in your application. And that can either be your entire application, or it can be a part of your application, like a subsystem or one specific project or something like that. It's part of the .NET SDK and runs on .NET Core. So what that means is that if you have .NET Core on your machine already, then you already have F# on your machine. Right? The .NET Core SDK comes with the F# compiler and the F# core library and templates so that you could do stuff with F#. So if you have not downloaded the .NET SDK, I highly recommend that you do, not just for F#, but just so that you could try .NET Core and .NET Standard and so on. But yeah, getting started with F# there is super easy. And another cool fact is that it has ubiquitous tooling support, right? It's supported in Visual Studio. It's been like that for a long time. But it's also in Visual Studio for Mac. So if you have a Mac and then you install Visual Studio for Mac there, it's also installed by default. And they have a bunch of different project templates and things like that that you can get started with. And if you also then install .NET Core with Visual Studio for Mac, then all of the templates that come with .NET Core for F# are also in there. Right? It's supported in Visual Studio Code with a plugin called Ionide. Well, it's actually a plugin suite called Ionide, and there's a specific plugin called Ionide F#. If you search in the extension marketplace for Ionide or F#, it's like the first one. And it's also supported in the .NET CLI. And it's also supported in JetBrains Writer, so if you have that, that also comes with F# by default. And the reason why it's able to do that is because of a thing called the F# compiler service, which is just this cross-platform compiler service. It's basically an API into the compiler, and that's how IntelliSense and things like that are sort of generated. And so every single one of these tools, Visual Studio, VS for Mac, VS Code in the Ionide plugin, .NET CLI, JetBrains Writer, and so on, they all use the same sort of API surface area in the same compiler. So you can get sort of a ubiquitous tooling experience so that you're not forced to use a particular tool to use the language. You can take whatever environment you want and use F# inside of that. It's one of our explicit goals and has been that for the past couple of years. And that goal has kind of actually really come true now. And so that's something that I'm pretty excited about. In addition to being a functional programming language, it also has full support for objects and object-oriented programming. It's what we call a functional first language, not a, so like you can do objects in OO and stuff like that. Well, objects in OO are oftentimes viewed as sort of very different from functional and sometimes at odds with one another. And we kind of take the approach that that's not really true, in that interfaces are perfectly functional, right? They're purely about, I have these definitions and inputs and outputs and so on, and I want to create part of my system that conforms to a particular interface. Well, interfaces are also in .NET. They're kind of useful. And so that's why F# has them, and that's why they have objects and so on. Basically, the utility of objects and object programming come in. And so that's why we sort of say that we're a functional first programming language, and we don't do object-oriented programming. We do object programming, right? Because we're not orienting ourselves around the objects. We're using them as just another tool in our tool belt. Okay? So if you're curious about where F# is used, because you're like, oh, hey, cool, here's this language, and I'm sure he's going to have a demo or something like that, but who actually uses it and what do they do? Because that's something that you're really going to be able to sell like not a hiring manager, a manager on, or some other decision maker or something like that. One of our most prominent customers is Jet.com. They have hundreds of F# engineers that are just full-time building hundreds of microservices that are just churning through insane amounts of data in Azure. Right? If you have any use case for the cloud at this point, there's a chance that they're already doing that, and they're using F# for almost all of it. And they're huge advocates of F#, by the way. So if you're curious about kind of how they go and do stuff, you can look on their engineering blog, and they have a lot of really cool blog posts about how F# serves them well for event sourcing or something like that. So if you're interested in doing stuff that's like web and cloud related, you should absolutely check out their tech blog. And you can see how F# is a really good fit for that. F# also powers Microsoft Security Risk Detection, which is a product that we have that's basically fuzz testing as a service in Azure. So if you're unfamiliar with fuzz testing, it's basically what they do is they just go and they basically take a DLL and they just beat it to death with a whole bunch of different stuff. To basically find all the different weird little security holes that you may have in your application. And so sort of the rules engine for all of that stuff, and then the rules engine for like scaling that out across like massive applications across all of Azure. That's also done entirely in F#. They also power NRK, which is the largest media organization in Norway. Think of it kind of like NPR, but in Norway. They have tons of backend services that they write F# in. Right, so there's kind of a theme there, backend services running in the cloud and so on, where functional is used. But then that's not all of it, though, right? F# is also used for desktop applications. I think the largest of which is the F# compiler and Visual Studio tools for F# themselves, right? F# is actually all implemented in F#. So if you have any doubts as to if it can be used, for Windows desktop applications or things like that, well, one of the largest Windows desktop applications in F# is written almost entirely in F#. And then it's also used in Azure anomaly detection. So that really, really important bit of Azure that determines if really weird activity was, actually you or something bad. That's a data science team basically figures that out, because this is a thing that's, it's a very hard problem. It depends on a lot of different things, and they do a lot of experimentation with F# and sort of, seeing like, hey, based on this kind of traffic, how are we, what sort of patterns does that sort of fit? They use F# for that as well. Okay, so there's a few characteristics of the F# language that I want to go over before I show you some code. Okay, immutability is the default of F#. So compare and contrast that with C# and Java, right? C# and Java are very, everything is mutable. You have to opt in to immutability. It's kind of a pain. It's not really all that fun. You got to add a whole bunch of keywords. Like with Java, you got to go final everywhere, and C# you got to go read-only everywhere. In F#, it's the opposite. Everything is immutable by default, and then you opt in to mutability based on when you actually need it. Because as it turns out, when you're writing kind of normal code, you don't really need stuff to be changing in place all the time. You kind of just want to say, hey, I want to bind the results of this function to a value, or I want to take this value and I want to pass it to a function. Well, there's no reason for that to be mutable, and so that's why it's immutable by default. Okay? Type inference is used for everything. So if you're familiar with var in C#, which I'm going to assume almost all of you are, just imagine that, but on steroids, like for everything. That's what F# is all about with type inference. It uses an algorithm that's based off of Hindley-Milner type inference, which is a way to basically say, based on how you type your code, actually give it a concrete type so that it's a compiled language rather than like a dynamic sort of thing. So you still get the benefit of compile time checks for making sure that types map correctly. But you don't need to go and type everything either. This is something that you can do yourself if you want. And in a very few sort of edge cases, you kind of have to disambiguate a type or something like that. But for large swaths of F# code, if not the majority of it, everything will just be using type inference. Right? So it's not just locals. Use type annotation to disambiguate. The kind of core of F#, by being a functional first language, is functions operate on values and other functions. Okay, so functions are also first class in F#. So that means a function can take another function as inputs, and a function can produce a function as output. You can pass functions around just as if they were values, right? So similar to how in C# you might have, You might new up a class or something like that, and then say that it's of an interface type, and then pass around that interface type, and then invoke or something like that. Well, instead of needing to sort of set that up by yourself, you just write an F# function, and you just pass that F# function around kind of wherever you need it. That's if you've been doing other functional programming, or if you do kind of a bit more advanced programming with JavaScript, then you should be fairly familiar with this. First-class functions is also like func and action in C#, passing around funcs and actions and that sort of stuff. That's basically the same concept. And then the other half of F# is about a powerful type system that you use to model data. Right? There's more than just classes, even though they're there. And classes are great for modeling some data, but they don't give you everything that you need. And I'm going to show you what some of that actually means. Specifically, there are two types known as records and discriminated unions. And records sort of let you just sort of aggregate a bunch of data into a type-safe way. It's very sort of lightweight. And then there's discriminated unions where you can say, like, hey, this thing could be one of a number of cases, right? An employee could be, just a worker, or it could be a manager who has workers, working for them, and so forth. And you may want to represent that in your domain. And you can use the type system to do that directly, rather than have to sort of mold your objects to sort of do that for you. Okay? And then you basically use pattern matching to act on the shape of the data. So, sort of you define a type that represents whatever your domain is. You have an instance of that type either generated by another function, or you generate it yourself, or something like that. Maybe you pass that to another function, it produces another type, and so on. And then you get something back in return, and you need to pattern match on the shape of that data, right? Because in that case of an employee example, you may dispatch functionality differently if it's just a worker versus if it's a manager that has other workers, and so on. And so functions operate on values and other functions. You use powerful types to sort of form a good compiled sort of representation of data that you're operating on. And then you operate on those types with pattern matching. And so this kind of, for the most part, basically ends up with a lot less code to do things. There's various little edge cases, like in any programming language, where something may be, a little bit awkward here and there or something. But by and large, you're going to be looking at significantly less code to do stuff. Perhaps even an order of magnitude, depending on the thing that you're doing, especially if you're using a lot of discriminated unions to represent data which could be one type or another. So that's kind of a little pitch about F# characteristics. Okay? So rather than just babble on about F#, I think I'm just going to show you some code, because if you're not familiar with the language, then it's kind of helpful to have that. Okay. So just quick question. Everything on the screen here, can you see that? And I type that. Can you see that that says .NET New fairly easily? Okay, cool. All right, so, yeah, I could .NET New, it's a whole bunch of stuff. I had to blow up the font. It usually looks a lot nicer when you're working on your own machine. You can see there's a whole lot of things, F# kind of everywhere here. Just because this is pretty basic, I'm going to show you, just a console app and sort of play around with the language so you get an idea of, what values, functions, and types sort of mean in the context of F#. Okay? All right, got ls, cool. I'll go .NET New console dash ling F# dash o. I got a type. There we go. Demo 1. Cool. Okay. Gonna go in here. There we go. Okay. So another quick question. People can see this code, that sort of stuff. You don't have to squint really hard. Okay, cool. So what we have here is a basic hello world. It's probably the most uninteresting F# program of all time. But there's a few things that I do want to point out before I start typing code, because I want you to be aware of what these very basic constructs actually mean. Right? So first of all, I have this open system thing right here. This is just the same as using namespaces in C#. It's just called open. And there's no semicolons, because you type less code to do more stuff in F#. Okay? You can hover over it, and you can see this is actually an unused open statement. So what I have here is Visual Studio Code with the inite F# plugin, and it's actually already run some diagnostics on this document and said, hey, you're not doing anything with the system namespace, so why do you have it open, right? This little light bulb's a little small here, but I can actually go ahead and just remove it if I want to. So if you're coming from a C# sort of editor experience and you're expecting tooling like that, well, we already have that tooling, and it's everywhere. It's not just in Visual Studio. So next we have the entry point attribute, right? So look at this. This is called a type signature. It's called a new unit, and then a little arrow, and then a thing called entry point attribute. I'm not going to go over like the specifics of what that means, but this is actually a class. And this is sort of showing, you know, the constructor for the entry point attribute, which is defined in .NET. And, you know, it takes nothing as input, in this case, unit or void as input, if you will. And the constructor produces an entry point attribute. So, you know, if I hover over something else, like argv, you know, it's a string, little open bracket, close bracket, that says it's a string array. If I hover over printf, it's got another big sort of thing here, but that's because printfn is actually kind of a complicated function under the covers, and it takes in a format string and then values that you can pass to that format string. You know, so I can do this. I can go, hello world from F#. I'm %s, right? And now I get a bunch of little squiggles here saying this expression is a function val that's missing arguments, right? So it needs to take a string, because what I've done here is I've actually put this %s thing here, and we actually have type-safe format strings in F#. So because I've said this format, it needs to print out a format string, and that format string expects another string inside of it, but I haven't supplied that string. So because of that, I get a warning telling me that I need to go ahead and do that. So I'll just go ahead and do that. Okay? So I can just save it, and it's pretty happy. Now, if I run that, whoop. I'm a terrible speller. Then it's going to compile. Hello world from F#. I'm Philip. Okay, so also fairly uninteresting, but we'll be doing some cooler stuff here pretty shortly. Just go ahead and delete that line. Okay, so argv, based on convention, it's a string array. If you're familiar with sort of how any of that sort of stuff works, it's kind of always a string array that comes into the entry point of an application. Well, let's do something with that, right? So let's print out a little greeting. So I'm going to define a new function called getGreeting, and it's going to take in a name. Okay, I'm just going to type that out. I'm going to go sprintf, get the nice little IntelliSense to help me out because I'm lazy. Hello there. %s name. Cool. So notice how I didn't have to declare that name is a string. I didn't have to declare a return value or anything like that. I just defined a function, right? In this case, getGreeting. And if you hover over it, you can see the type signature says, name is a string, and then it produces a string as its output. And the reason why it does that is because sprintfn itself produces a string in this case because, I passed in that sort of thing here. And so it's able to infer that, okay, well, this whole thing has to return a string. And then sprintf itself expects a string as input. And then I'm passing this thing called name in as input. So therefore, name must also be a string. Okay? If I changed it and made it an int, right? Well, now name is going to change to an int because %d is the way that you specify an int there, right? So let's go back here and do this. And then we'll take argv. So in this case, I'm going to run the application, and argv is just going to be an array of names. And so because those are going to be interpreted as strings, let's go ahead and do this. So we'll go argv. Okay. I'm going to use this thing called a pipe operator. There's a couple of different operators in F#. You can also define your own operators. There's an infix operator that takes in basically something on the left and something on the right, and then it turns it into a function call, right? So I'm taking argv. I'm going to pipe it into array.map. Right? This is very similar to select if you're doing stuff in LINQ with C#. Okay? And I don't actually need a Lambda expression here because I can just pass in the F# function directly. Okay? So what I'm doing here is I'm piping this array of strings into a function that takes something and maps it into something else. In this case, I'm taking a name that'll just come from standard in, and then I'm going to convert that into a greeting that's defined by this function right here. I can do anything in this function just so long as it actually returns a value. Okay? And then we'll just go array.iter, which is, to iterate. We'll go fun, greeting. F# is fun. That's why Lambda expression used the fun keyword. We'll go printfn, greeting. Okay. Let's go ahead and run this. .NET run, Philip, Andrew, that's my boss. Kendra, that's my office mate. Okay, hello there, Philip. Andrew, Kendra, okay, cool. That's kind of cool, but not, I don't know, it's kind of boring. I think I want to make it a bit more interesting. We'll go engaging VS 2012 mode, because if you notice, these are, kind of sentence case. I was a really big fan of Visual Studio 2012, and particularly those all caps menus. So what I think I'm going to do here is turn this thing into an all caps greeting rather than a normal greeting, right? So the return value here is printf. So I want to do something else with this. What I'm going to do is I'm just going to bind with a return of printf into another value. Okay, so I'll go. Okay, that greeting is printf. Hello there, something like that. Well, this block following this let is unfinished. This is a common error message that you're going to get if you're just trying out F# for the first time and you're doing this sort of thing. What this is saying is that functions need to return something, right? That's the whole point of a function. And what I've done so far is I haven't actually returned anything. I've taken printf and I've called it and I've assigned it to a value, but I haven't done anything with that value and I haven't returned something else. So I get a compiler error because if I were to try to call this, well, it's like, hey, I can't call a function that doesn't return anything because what am I going to do with that value? So we'll just go greeting dot to upper. Okay, and because I don't quite want to run this in with the .NET run command or something like that, I'm going to go hit Alt Enter. I'm going to send this to F# Interactive. So something just happened here. Actually, I think I need to adjust this font here really quickly. Integrated.font size, we'll make that 24. Okay. Oh, yeah, that's much better. Okay, cool. Okay, so what I've done here is I've sent this to a thing called F# Interactive. This is another very critical component of F#, especially if you're learning, is it's F# Interactive. It's an interactive process that's actually launched, and what it does is it accepts arbitrary F# code, and it goes ahead and just executes it inside of that safe sort of process that has running. Then it returns a result. So what I've done here is I've executed this function, and so what you see here, kind of up here, is sort of, this is the equivalent of what F# Interactive was passed. And now it says I have, val get greeting, name, string, arrow string. Okay? And it's saying I now have a function value called get greeting that takes in something and produces something. So we'll go get greeting, Philip, and I got to do this little double semicolon thing. This is a way that you would sort of say, hey, that's the end of the buffer that you want to send F# Interactive. Oh, there we go. Now it's in Visual Studio 2012 mode saying, hello there, Philip. So this seems to be doing what I want it to do. Let's just double check that this actually works. Because I have everything in lowercase here, and we want to turn it into uppercase because that's what true greeting messages actually do. There we go. Much, much more beautiful. Okay. So that's kind of all fun and games. This isn't particularly serious programming, but this is actually quite intentional because the core of what is functional programming in F#, just acting on functions, taking data, passing it to functions, acting on that result, doing something like printing it out, something like that, that is the core of what you do in all of F# programming. And although this wouldn't necessarily be a whole lot of code if you were to do it in C# or another object-oriented language or something like that. It's just not a whole lot of code to actually take some input and then produce it, produce some other output based on, some other functionality. I could do something crazy inside of get greeting here. But to sort of show you that whole less code to do more stuff thing, I'm going to do something with discriminated unions in F#. So who here has gone to a job interview and asked to do something kind of stupid on a whiteboard that had nothing to do with the actual job that they were supposed to do? Yeah? Yeah? Okay. That's like every interview. It's wonderful. Well, one of those things, it's not guaranteed to involve binary search trees, but it oftentimes does involve binary search trees, and there's a pretty good chance you're never going to actually use binary search trees in the rest of your job. So you really just kind of want to get that done as fast as you can and just get out of there, right? So you can use F# as your tool to do that, and it's one of the best tools for doing that. Okay? Okay, I'm going to define a binary search tree. I'm calling it BST, and I have this little funky syntax here with this little tick and a T. That's how I specify a generic type in F#. Because in F#, there's actually two kinds of generic types. There's the regular F# generic types, which are just .NET generics, and this is our way to represent them. But then there's also statically resolved types, or statically resolved type parameters, which is a thing that's actually evaluated at compile time. And so that's kind of more useful for kind of ad hoc polymorphism, or sometimes it's used in some little metaprogramming or things like that. And it's not something that you really reach for all the time, but it is sort of helpful. And so that's why we have syntax for both of those kinds of generics. 99% of the time, you're just going to be doing this tick the whole time. Okay? So like just about everything else in F#, I'm going to put a little equal sign. Okay? So a BST has to have some kind of definition. So if you recall what a binary search tree actually is, you've got a node with the value, and you have the little pointers to your other nodes, and those nodes may be empty. They may not have anything in them. They may have children that are empty or something like that. So you can actually represent it just in 3 lines of code, right? So there's the empty case, the binary search tree. Then there's a node of T, right? Because this is a binary search tree of type T, so we want to have a value that's of type T, right? And it's going to have a left subtree. And it's going to have a right subtree. Okay? And that's all there is to defining a binary search tree in F#. Right? If I hover over this, you'll notice that it's a slightly different tooltip. It says, union BST. This is a discriminated union. And it shows me the actual definition of the type in the editor. So if I were to be consuming another library written in F# or something like that, and they exposed a discriminated union for me to interact with, I could hover over that in the editor and see the type without having to navigate to it and that sort of stuff. You notice that I kind of left this kind of naked, if you will. You kind of have to infer that T is the value, this is the left, this is the right. I can actually label them like this, right? Okay. And if I hover over, you'll notice that the label's in there, the font all blown up, so it's it's not on one line. It's much prettier normally. It's saying value is the T, left is this one, right is this one, and so on. And so this is not necessary syntax to do this, but in this case, because I may feel that it helps clarity for other developers on my team to sort of explicitly label these sorts of things, I can go ahead and do that whenever I want to. Okay. So the next step is, I think there was a really interesting blog post that I read about a guy who he implemented the package manager on Mac, and he was interviewing for a job at Google, and they denied him because he had trouble flipping a binary search tree or something. And it's like, wow, you built an entire ecosystem of stuff, and you couldn't flip a binary search tree. That's kind of interesting. Well, if you'd used F#, then this would have been a lot easier. Okay, so traversing a binary search tree, or just any sort of tree-like structure, is usually going to be a recursive operation. And so recursive functions in F# are very common. That's sort of the way that you go and just traverse any kind of structure in general. Or you can use recursion through a list or something like that. It's a very convenient way to do stuff. So the way you write a recursive function is very easy. You just go let rec, right? Rec is the recursive keyword, right? Let's call it flip. I'll take a BST, or a binary search tree, right? So right now, notice if I hover over this thing, it doesn't know what this type is. This is actually type inference at work right here, because I haven't used this in any meaningful way. So the compiler generalizes this type. It's called automatic generalization. And so basically, when you actually have a value as input and you're not doing anything that signifies what it actually is, right? The operation that you're performing on it, well, in this case, I'm not doing anything, but say I were to just return it back, right? Returning something back does not, it does not depend on what the thing is, right? So the compiler is able to sort of infer based on usage of something what it is. And if you're using it in a way that is entirely generic, then it will actually automatically infer it to be generic for you. And this is pretty helpful because oftentimes you can end up writing F# code, or just kind of any code, honestly, that really is generic. It's not, there's no concrete thing that you're doing on something. But in F#, it just basically gives you that for free, right? You don't need to already know that I'm doing something generic. Now, I would argue that you probably should know, but it's helpful that the compiler can let you know that you're doing that, and you can just hover over it and see that you're doing something that's generic. And if you think that's a good idea, you can keep doing it. And if you think it's not, go ahead and move on. Okay? So back to flipping a binary search tree because we're in a job interview or something like that. This discriminated union type is either an empty case or a node that has some stuff inside of it, right? That has a particular shape. It could be one of those two cases, right? I mentioned that you operate on data via pattern matching. Well, this is, if you're familiar with the newer pattern matching in C#, this is like that, but like totally on steroids. It's way better, okay? All right, I'm going to match the BST with. Okay, going to specify this little bar here. You'll notice there's a bit of symmetry between pattern matching syntax and the type definition syntax for discriminated unions. It's not an accident. Okay, so in the case of the empty BST, I'm just going to go ahead and return whatever it is. Okay. Then in the case of a node, okay, there's a little constructor there. It's actually, it's ugly because of the blown up font. But normally it's on one line, and you can see it takes in a value and that sort of thing. What I'm going to actually do, this is the empty case, but this is the node case, right? X, left, right. So what I've done here is I've deconstructed this, if you will. This is like a deconstruct. We just call it pattern matching syntax. We don't have like this special terminology for deconstructing a thing, right? It's the constituent parts of a binary search tree are the value of the left and the right subtree, right? So you just call it that, and it works, right? So now, based on the shape of that, well, we want to construct a node that has that same value in there, obviously. So we'll construct a node that has the x. Then we'll just call the flip function on the right subtree inside of where the left needs to go, and then we'll call the flip function on the left subtree where the right needs to go. Okay. And everything now compiles. The editor's pretty happy. Flip, all it does is take a binary search tree and produces a new binary search tree, right? So we can actually test that. Okay, let's go ahead and get rid of this VS 2012 mode. A joke that did not elicit many laughs. I'm going to have to write that down as never to do that again. Okay, so we're going to construct a BST first because, like any good coding interview, they're going to ask you to make sure that it actually works. But then, strangely enough, not give you a laptop to test it. So we'll construct a new one here, okay? So the way that you construct one is, I don't call like BST, right? Because BST itself is not like really a thing. It's really just a representation of something that is either empty or a node with some stuff inside of it, right? And so if I want to construct a concrete instance of this sort of thing, I do it via the constructor here. So you'll notice that node has this of keyword, of value left right. Well, if I go here. Okay. I think that was having a little fun there. But I need to actually do the constructor right here. So before we do that, let's just type this out in comments here. All right. Okay. So like a little 3, 4, 5 tree or something like that should probably work. All right. We'll go 3. Okay. No, that's got to be 4. So that's how these things work. All right. Okay. So we're going to make it look like that, where 4 is the root, 3 is the left, and 5 is the 1. And then, 3 and 5, they have empty subtrees on their end there. Okay, so we'll go node 4 as the root, and then another node, which will take in 3, this is the left subtree, and empty. Okay. And then another node that takes in 5, empty, and empty. Cool. Oh, I missed a little comma there. So you notice that I got error diagnostics for this specific node right here. However, this constructor is applied to 2 arguments but accepts 3, right? So node accepts 3 things, but I've passed in a thing called empty empty, which makes absolutely no sense. The compiler is telling me, hey, this needs 3 things you passed in too. So put a little comma in there, should work. was actually not intentional. I just forgot the comma, so it's kind of fun. Caught myself there. Okay, so we'll call it flipped, right? And you just call it flip, BST. That's all you do. You don't have to do anything special. Okay? Did I have a little funny thing in there? Oh, yeah, let flipped. There we go. Got to put a little equal sign in there. Okay. So now we'll just print this out. Okay, we'll go BST. I'll do this thing called %A. So I'm throwing a lot of little percent signs in here, but if you're learning, these formatted strings are like a really good way to learn because you can play around with all sorts of different data types. A is your magic thing. What this does is it actually invokes a pretty printer that we have in the F# core library. And based on the thing that you pass into it, it uses reflection to sort of traverse the structure of it all. And if it's a large enough structure, it kind of cuts off after a while and says, hey, there's more stuff here, but I'm not going to go ahead and do that. But so I don't need to define a routine for how to print out this thing, because that might actually be a non-trivial amount of code to print this out. Well, I actually know that it's not a whole lot of code because it's just a very simple data structure. But you can imagine a more complicated one, and you don't have to actually do that yourself, especially if you're doing exploratory stuff like this. You can just do %A, and things are totally fine. Okay. And we'll put a new line in there, and then we'll call flipped. We'll do a %A. Bunch of new lines in there. All right. So I passed in two big old A's here. I need to pass in two things, right? BST and flipped. Okay? Now the editor's pretty happy. Okay, so let's go ahead and run this. Okay, so you'll notice the BST, it said, node, and then there's a 3 subtree, and then there's a 5 subtree coming after. And now it's flipped it, so 5 is the next subtree, and then 3 is the next subtree there. So this is a pretty powerful tool, not just for interviews, but if you are in an interview situation where you need to flip a binary search tree, you can do it in 1, 2, 3, 4, 5, 6, I guess 7 if you count the white space, 7 lines of code. That's pretty easy to write on a whiteboard. And all joking aside, that's actually a really good thing because you may want to model your data in a way that's very convenient for you to write down, but transferring that into actual code is sometimes not the nicest thing in the world. But if you do it with discriminated unions, it's actually fairly straightforward. Okay. So split back here. This is going to take a little bit of time there. Quick little recap. .NET New type --lang F#. You can do a bunch of different stuff there. This is just download the .NET SDK. Just start playing around with that. Hopefully I demonstrated that basic F# syntax can kind of go a pretty long way. You can do some interesting stuff. And then VS Code and Inide rock. They're pretty cool. Okay, but little console apps to kind of explore stuff is not the only use case for F#. So let's go over to this guy right here. Okay. As a quick order of business, you'll have noticed that there were a session 1 and a session 2 of this talk, why you should use F#, part 1 and part 2, with slightly different abstracts. Well, it's not an accident that they're jammed together. So rather than skip away for a bit and and then come back or something like that, I'm just going to keep going until the end of where the second one goes. So because I think there's more that I can certainly show you. So here I have something that's kind of cool. You see this thing called Web Demo in Project Explorer. Sorry, Solution Explorer. I am not going to publish to Azure on this conference Wi-Fi, I'll tell you that. But this actually just came from a file new template inside of the latest update, VS 2017 15.7. So you can just go there, file new. There's a little Visual F# dongle. If I do that, it's going to close this solution, and because I'm on a virtual machine with I think I might have Docker running or something like that, it might be a little slow. Oh, you just find it there, and there's an ASP.NET Core web application. It uses the same UI that you would get with C#. And tooling just sort of lights up, right? If I was so inclined, I could publish this to Azure right now. I'm not going to risk that on the conference Wi-Fi. So if you're familiar with ASP.NET and ASP.NET Core, This should be fairly familiar to you all. There's a program.fs, startup.fs, and a controller called values controller. Well, inside of that values controller, there's some funky little syntax. All right? So, oh, you want this a little bigger? All right, I'm going to do that. All right, cool. So, there's the open statements. You know what that's all about. There's this thing called route, which, if you know about ASP.NET, you know that you do routing. It's pretty straightforward. This is attribute syntax. You notice there's the little bracket and, the little less than sign, a little greater than sign. That's just how you do attributes. And the way that you do ASP.NET routing with attributes in F# is the exact same way that you do it in C#. You just have this, a little additional character at the front and at the back. And then you decorate this type where I want to call out something important here. This type has this thing right in here, this little parentheses. This is actually a default constructor. So if you're familiar with default constructors, this is just, I don't have to specify an actual constructor inside of here to do something. I can actually just, take in, values, something like that. And this actually might not work in here because there's like special ways that constructors are sort of wired together in ASP.NET. But in normal classes, you can just have, you can just have stuff like that all the time. And then when you actually invoke this values controller type, you just pass in stuff directly. So it's less syntax for that object programming, which is kind of nice. And so in this case, it's inheriting from the base controller type. So that's just how you inherit from something. And then I have a couple of members here, right? So I have a member called get, a member called get again, except this case it's overloaded with a new input parameter called ID, which is an int. You could modify this to be anything you want. You could do these from bodies, that sort of stuff. Right, and so this is just, your nice little value1 value, that sort of stuff. Let's just pull these out into a little letbound value inside of the class. So what I've done here, oh, hey there. What I've done here is taken values themselves and just extracted them into the definition of the type. So I have a letbound value inside of the class. Right. This is very similar to like if you had a field that just had some data inside of it, and you wouldn't do this in production unless you do values as a service or something. But this, if you just want to have some letbound data inside of the class to do stuff, sorry, I'll take questions at the end. If you just want to have some values kind of inside to do stuff with, you can just do that. It's very straightforward. There's no additional syntax to just hold some data inside of a class. And this is properly encapsulated, so you can't actually access this values from outside of the class. It's private. There's actually no way to make it public. If you want to access data from a class, you need to make it a property or something like that. That's just how you do stuff in F#. So we have this right here, little values, in this this indexer syntax. You'll notice that I just did something slightly different. Rather than, doing that, I did that. That's because indexer syntax uses, the thing, in this case it's an array, and then dot, and then, the index that I'm indexing into. Okay. So do the little clicky debug. I would have hit F5, but my little dynamic display on the MacBook Pro changed, and I don't have access to the function keys because I'm plugged into some interesting stuff here. Okay, so it's just going to run like any other happy little localhost application, and it's going to give me an error page because that's just I haven't actually accessed the API itself, right? So API is value 0. Okay, well the 0th value is value 1, right? If I go, whoa, that didn't work. Well, that's because I'm indexing directly into an array. It's not very safe, right? How many times have you done that? I've done that plenty of times. Well, there's ways to sort of access data in a bit more of a safe way, okay? So rather than doing this, dumb little values.id thing, I have no guarantee that a value kind of of that particular ID or at that index, basically, at this point, actually exists in the data set that I'm trying to access from, right? Right? So you want to be able to have this notion of, does something exist or does it not exist? And if it doesn't exist, I need to do something different, okay? So, right? I'll define a new thing here, and I'll go call it res, short for results. Then I'll take values. I'm going to pipe it into a function here called array dot try item. All right. You notice there was a whole bunch of stuff in the IntelliSense list there. This is just all part of the F# core library. So arrays, there's these array type functions. Array.try item takes in an index and produces, takes in an index, takes in an array, and it produces an option. Right. So I'm going to introduce the option type right here. Okay. Okay. So I'm piping values into that. So just for a bit more clarity, I'll put that on this new line. Okay. So I have a value here called res that's a string option, right? This is very different from just a string, right? And so what try item actually does is it goes and it tries to get the thing based on how you specified it, and if it's not there, it'll return a thing called none, right? Instead of the actual value. This is an optional type. So what I'll actually do is just pattern match on the result here, okay? So some value, right? This is saying, hey, there was something there. This is actually wrapped the value in a union case called sum. This is how you sort of extract that out there, right? We'll just return the value. That's all good, okay? But however, over here, incomplete pattern matches on this expression, okay? I'm pattern matching on a thing that's an option, and I've pattern matched on, the sum case, and then I've said, okay, that should be enough, right? Well, no, that's not enough, and the compiler's yelling me about that because I have not accounted for the case where there's nothing there, right? So this is, again, the F# compiler being awfully helpful. Okay? In the case of none, I'm going to do a little sprintf. No value of index %d. Okay. ID. Cool. So if I go ahead and run this again, once the build succeeds and it actually launches. Okay. No value of index 123, right? So in this case, rather than doing something like indexing in there, I'm able to utilize a built-in discriminated union called the option type and be able to represent the case of either there's something or there's nothing, right? Well, so this is a really, really common one. That's why it's in the core library. You're going to be interacting with APIs all the time in F#, including your own APIs, where something may exist or it may not exist. And this is a way to represent that in a type-safe manner and sort of make sure that the compiler is like okay with you interacting with this stuff. And if you're not accounting for all the different cases, it'll yell at you, and that's a rather important thing to do, especially when you have a more complicated domain and you have like various error cases that could occur through natural program flow or something like that, and you want to actually handle that error case on a really a really convenient way. So that's what I have to show for F# and ASP.NET Core. Right, you can write web services with F# and ASP.NET Core, obviously more than just a dumb little value service, but the tooling's all there, the product templates are all there, you can start doing stuff. There's a lot more than just ASP.NET Core for F# on the web. There are libraries such as Suave, and Suave and Giraffe is another one. Giraffe is actually a very functional programming sort of API routing layer on top of ASP.NET Core. And so it's basically a different syntax than ASP.NET MVC, but it uses the same underlying web server that ASP.NET MVC does. And so it has very similar performance characteristics. There's another one called Freya, which is like mega functional. So if you're really into type theory and functional programming, go play with Freya. And then there's a new one coming out called Saturn, which also runs on ASP.NET Core, and it uses a very, very, very different routing syntax using a feature called computation expressions that are much more advanced. I'm not going to get into it here, but it's modeled kind of after on Ruby on Rails, and if you're familiar with the web framework Phoenix for Elixir, it uses a very similar sort of model for routing things and setting cookies and things like that. And so I recommend playing with all of those, right? Hopefully, I kind of demonstrated that object programming in F# is pretty easy. You can just the template already shows you how to define a regular type and methods and things like that, and it's nothing crazy, right? You just define a type, it has a default constructor, you have some methods, that sort of stuff. VS support for F# and .NET Core is pretty radical. I didn't get a chance to do some refactorings there, but I'll show you more of that here in a bit. Okay. Then I do have one more thing that I want to show you. Okay. Oh, right. I want to go recent projects and solutions. Okay. So I'm going to show you something called type providers in F#. I didn't mention what this was. Type providers. Oh, that's kind of a lot. UI is a little small here, but if you look under the NuGet node, there's a thing called fsharp.data, version 3.0.0 beta. This is all running .NET Core and .NET Standard. Okay, so I got the same thing right here. But so, say I'm scraping the web, or I'm a data scientist, or I'm doing something with some data, and I don't really know what I'm going to do with it yet. I need to explore the data. I need to sort of figure out what's going on in there before I start, integrating that into my actual application. Specifically, we're going to take this list of megacities from Wikipedia, because I don't know about you, but I'm always browsing Wikipedia and just like trying to look for like random facts, specifically when it involves cities, geography, and just, I don't know, various things like that. Right? So we'll go open fsharp.data. Okay, cool. Fsharp.data comes from the NuGet package fsharp.data. So just look for that in the NuGet UI, or you could just add it in the in here itself. Fsharp.data 3.0.0-beta 3. It's going to be out of beta pretty soon. This is all .NET Core and .NET Standard, so I could be running this, anywhere, not just on Windows, right? But so, okay, I have that megacity stuff. So let's do this. Literal, okay. I'm defining I have a new attribute that I'm kind of going to put on a value here called literal. Okay. And just to be safe, I know that I don't actually need this, but I'm just going to put it there anyways. I'm using this @ that specifies, it's a string literal, or I could do that. But literal right here is an attribute that lets you do something really cool like this. Okay. So we're going to go type megacities equals HTML provider. This is where things are going to start to get a little funky here. And I'm going to pass URL into the type parameter of this thing, right? So a type provider is a thing that you point it at a data source. Could be anywhere. Could be a file on disk. Could be some resource behind a URL. Could be just hard-coded into your editor or something like that. Could just be a schema file somewhere. Could be live data. It doesn't matter what it is. You point it at that data source. And what this does, actually, at design time, right? Actually, in the editor right now, it actually goes to wherever that data source it is. It reads it. It figures out the shape of that data. And then it builds out an object model for that data. It passes that object model to the compiler. Okay? And so because we invoke the compiler through that F# compiler services thing that I was telling you about, we actually have access to that object model, and we can get IntelliSense from that. Right? This is really, really wicked cool if you're doing data exploration or just general data access stuff, right? With a SQL database, you want to have, strongly typed access to your tables and that sort of stuff. Well, the past way you did that was this complicated machinery of just having some contracts here, and, it's actually just hard-coded strings on the inside, and, hopefully that works. Right. We'll just call do stuff here, because I'm not entirely sure what I'm going to do yet. Okay, so I got my do stuff function that's going to do some stuff. Well, I need to access that data. Okay, well, data equals megacities, there we go. Megacities dot, I have a few options here. Get sample, async load, load parse, that sort of stuff. I'm just going to call get sample. This is actually on the UI thread. If you were to do stuff like in an actual application, you would probably call async get sample or async load, and that would do it asynchronously. But you'd have to then do that inside of an async function, and I'm not going to bother with that right now because we don't really need that, right? So if I hover over data, it's of type HTML providers something. Okay, well, we'll go let stuff equal data dot. I have some options here. I have a thing called tables and a thing called lists, a thing called HTML. Well, Wikipedia has tables and lists, right? If I go here, this largest cities, this is an actual table of data, right? So it was able to actually figure out that there's some tables in there. That's pretty cool, isn't it? Okay. Now we'll go let other stuff equal stuff dot. This is where it's pretty radical. Largest cities. You notice there's actually a space in there. It says largest space cities. And if you remember, it's called largest cities in the actual Wikipedia article. Okay? Right? Well, I get that in IntelliSense directly because it built out an object model from the HTML and produced that for me. This is actually lazily created, so you could have a massive HTML file, and it's not going to load it all in memory for you. It's going to just load what it needs at the time. Okay? Largest cities. Notice there's this double backtick syntax. This is how you're able to put like literally anything inside of here, and it's able to recognize it as an editor here. Okay, we'll go .rows. Okay, so tables have rows, so I can do something. Well, I don't really like this stuff name, so I'm just going to rename that, call that tables, because that's what it actually is, right? So that was a little fast, but that's the same rename UI that you get with C#. We have, some of these basic refactorings there use the same UI and sort of the same underlying, well, not the same underlying mechanisms, but a lot of underlying mechanisms that you get with Roslyn. And so F# is actually hosted on top of Roslyn in the Visual Studio, so it's pretty rock solid. Okay, so we'll have this other stuff. Okay, so that's the rows. This is actually, this is not other stuff. This is actually, largest cities, right? So I'll just go ahead and rename that. Cool. Okay, so just like the other demos, I'm going to pipe this thing into another thing. This is really common in F#. You're just going to take data, you're going to pipe it into other stuff. Okay? We go array.map, right? Because this is of type row array. Well, I don't know what a row is. I don't know how that's going to print out. That might be a little weird, right? So let me actually extract something out of that. Okay? So we'll go fun row dot. Even more of that type provider magic. It's not magic. It's a lot of hard work. There's this thing called, megacity, population, continent, country, image, rank. This is some pretty cool stuff. Megacity, I think that's the end of the actual name of the city there. Okay, and I'll put a comma there, specifying I'm going to turn this into a tuple, and we'll get the population there. Cool. Okay, so I know that there's a thing called megacity and population inside of that data based on what the HTML provider gave me. And now I've just converted that row in the table, HTML row, whatever that is, into an actual F# tuple of string and string, right? So I'll go good old array.iter here, and we'll go fun. I'm going to deconstruct this, right? We'll go city, pop. We're going to print. We'll go %s there. City. Notice that city is a string. Pop is a string. Okay. Cool. So I haven't actually executed this code. I haven't executed anything on this data set, well, at least myself. The editor's actually gone and done that. But I already kind of know the shape of this data without having to really deeply inspect it and build this kind of annoying little type that represents some subset of the data that I care about, and from some weird routine that just goes and reads the whole thing, but goes and gets a few pieces. Nobody likes actually doing that. So we'll just call do stuff right there. Okay. Make sure to start without debugging, otherwise the console output's just going to disappear. All right, this is running, and I wonder if there's I'm not going to bother trying to increase the font in here. But if you squint, you can see, there's Los Angeles, 18,000. There's Tokyo, 38 million. Shanghai, 34 million. Jakarta, 31 million. Delhi, 27 million, so on. I can actually see that, this number right here is, it was saying that it was a string. Well, it's got this little bracket 6 thing. Well, that's because that's actually the little linking thing that Wikipedia has. And so now I know that if I'm doing some data, exploratory data analysis on this set, and it's actually an integer, but it's coming back as a string. Well, the tooling here was able to let me know that, hey, this population should be a string based on the name, but it should be an int based on the name, but it's actually a string. Well, that means there must be something in there, based on the shape of this data, that it's not actually, a numeric value. And so now I know that, if I want to, maybe do something like sort by population or something like that, I guess I could actually sort by population here based on string, but it's not quite the same thing. It's like ordinal comparison, between characters and things like that. But I could write a parsing function that could go and find everything inside of the little brackets, right? Because it's not guaranteed to be just one, and then just strip all of that out, and then it'll actually know that it's a number, and then I could sort by that number or something like that. And so there's sort of this back and forth, especially with data analysis and just kind of exploring stuff with F Sharp, because that's just kind of that's what data science is all about. Actually, is just cleaning data, and data is never going to actually be the shape that you want it to be in the first time. And so, rather than learn that the hard way and spend a lot of time, say in Python, debugging really stupid runtime errors that you kind of don't really understand, or at least I don't understand them, you can go in and just get that sort of stuff in IntelliSense and know, hey, this population thing is a string, but I think it should be an int, so maybe I should try to do something about it. Well, let me print this out, see what it looks like, and then do some more stuff there, right? You can do that all within Visual Studio, all with F Sharp. You don't have to install like crazy stuff, like some massive data science pack or something like that. All this is a NuGet package that runs, it's targeting .NET Standard, so it runs everywhere. So I could have done this in inite, I could have done this in Visual Studio for Mac. I could just do that and install it into, my project and be good to go. So, type providers are pretty legit. I'm really happy to sort of showcase them here today because there was a lot of work that went into making them run cross-platform in .NET Core. Because they used to run only on Windows and .NET Framework for a long time. And as you can imagine, a mechanism that can point to an arbitrary data source, build an object model based on the rules of that mechanism, and pass it to the compiler, and then allow for a good editing experience to where you couldn't even tell that it downloaded the HTML and built out that object model while it was typing. It just worked, right? There was a lot of work, and so that's available. So the type provider mechanism now works in .NET Core, and you can build type providers that work on .NET Standard. I showed F Sharp Data, which, right? F Sharp Data is one that you can use today. It's in beta. There's a whole bunch of other type providers out there, right? F Sharp.data is for just like XML, JSON, things like that. But if you have a SQL database and you want to access your data in a bit more of a fun way, well, you can use the SQL provider, which also runs on this. There's also another one called SQL Command Provider. There's also another one that runs specific to PostgreSQL and has some optimizations there. There's a GraphQL type provider. There's a YAML type provider. There's type providers for just about every single data format that you want out there. And although not all of them run on .NET Core today because those packages still need to update to be on .NET Standard, they're already doing this. And F Sharp Data already works today. So, I wouldn't necessarily do this in production yet because, the ecosystem hasn't fully moved on. But, especially for learning F Sharp and just exploring stuff, check out type providers, check out fsharp.data, just play around with some weird stuff on the internet and have fun, right? Okay, so seen all that. If you want to get started, you can visit aka.ms/fsharphome, right? Let me just do that for you really quickly. Blow that up. This is a page that we have here. F Sharp is the open source, and it's a marketing page. But there's a big button on there that says, "Get started with F Sharp." Oh, geez. I have to switch the button. Thanks for letting me know. OK, so I typed aka.ms. F Sharp Home in the browser. This will take you there. This is a marketing page, but it's got a big button called Get Started with F Sharp. Go there. You can get started in 10 minutes. Download the .NET SDK. If you're kind of curious about what some language features might look like, you can check it out right here. There's links to our documentation. This is the F Sharp language reference itself that we have in docs.microsoft.com, and just look at all that stuff right there. Absolutely everything in the language is fully documented. We have guides for how to get started and so on that you could explore there. We explain what functional first means. There's a cool little F Sharp tooling page here. So if you want to see what's available to you, like where you can use it, well, everything that's listed here, you can use it. And I mentioned the inite page. So if you're curious about that plugin, we have a link to their homepage. You can check that out. And then lastly, there's a cool thing on, cool thing here. The F Sharp Software Foundation that we link out to. So F Sharp, it's not just a Microsoft thing, right? I mean, we have Microsoft employees working on the compiler, the tools, and progressing it and that sort of stuff. But it is fundamentally a community thing where Microsoft is a member of the greater F Sharp community. And so one of the center points of that community, the F Sharp Software Foundation, that kind of independently drives F Sharp, outside of just what Microsoft is doing. They register with, you can register an F# meetup with them and get it officially recognized, get a lot more visibility. It's 100% free to join the foundation. I recommend that you do. You get access to some forums that are really great. You also get access to a Slack where there's, well, I think about 2,000 active members at this point. There's a lot of people there, and there's a really active beginners channel. So as you're getting going, you can have actual experts in the F# community teaching you how to do stuff. So I recommend you go there, check everything out, especially on that webpage. I don't care if you check out, if you don't do anything that I showed in those demos or anything like that, just so long as you go to that F# home webpage and just try stuff out on your own, visit the F# Software Foundation page, get connected with the community. There's amazing people in this community. They absolutely love beginners, and they love helping people. So it's a really great time to get started. Okay? Download HANA Core, you probably have it. All right, that's what I got.